This is chapter 5, problem number 29. The magic number, the lucky number for this problem is 3. All right, let's look at the problem. Well, I'm sure you have read the problem. This is your homework assignment. I'm just going over it. All right, so you have, here's the Earth. Here's another planet. Okay, well, they're not close to each other. We just try to do some calculation. On Earth, what is the gravitational constant? Okay, that G over here is equal to 9.8 meters per second square. Let's say on the other planet, it's not 9.8, it's not the same size as the Earth. On the question is given as 12.0 meters per second square. So you have a 24 kilogram object. What is the weight on Earth and what is the weight on that planet? And what is the mass on Earth and what is the mass on that planet? All right, so let's talk about how we measure the mass. The mass should be the same no matter where the object is. Okay, so let's talk about the weight. We know that the weight will be heavier over here. Why? How do we calculate the weight? The weight on Earth, or the force, is equal to mg, which is equal to 24 times 9.8. Okay, that would be Newton. Over here in the other planet, it will be equal to m times the new g. Okay, this g will be 12.0. It will be equal to 24 times 12. It will be Newton. All right, so the weight will be different. That means if we go to a heavier planet, our weight will be higher. If we go to the moon, and therefore our weight will be lower. That's why people can jump higher in the moon. Okay, what about the mass? Okay, so the way that we measure the mass is by, well, the way that we measure the force. Let's say we have a spring. Okay, so over here, if this is how it behaves on Earth, when you go to the moon, what will happen? Because the moon has less gravity, so it will not expand that much. Okay, so that's how you measure the force. But how do you measure the mass? All right, so the mass is measured by using a balance, and we're comparing to a standard mass. Let's say this is 1 kilogram. Okay, and if it balance, this is your object. If on Earth it balance, and if we bring to the moon, the gravitational force on the moon will be smaller. However, both sides will be smaller but by the same factor. Okay, so when you go to the moon, when you measure it, this one will be 6 times lighter. However, the object will be also 6 times lighter. So when you go to the moon and you do this balance, you find that it's balanced. So this is also 1 kg in the moon. So the mass is independent of where you are and is independent of gravitational force. However, the weight would depend on how big the planet is. Once again, the lucky number for this problem is 3.